Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Abu Hurairah bin Muhammad Yusof. I would like to present my final year project proposal. Okay. My title is Development of a Microsleep Detector Device MDD for Driver Sleepiness Detection. Okay, this is my project summary. The goal of the project is to create a device that can detect drowsiness of drivers with facial features such as EAR, YAR, and per clause. The project's goal are to identify drowsy drivers' behavior, develop a tool to measure drivers' sleep level of tightness, and confirm if gender influence this action, to accurately simulate real-world driving conditions without any disruption or obstacles. The research will use a driving simulator made in Unity 3D. The collected data will be evaluated to conclude the bin graph and categorized. The Karolinska Sleepiness Scale (KSS) will be applied and modified to measure drowsy driving behavior. Okay, this is my introduction. Microsleep is a condition that someone sleeps for just several seconds. Most of the time, people did not realize they were in that condition. Moreover, if this condition occurs while driving, an awful result of the accident might have happened to the driver and also to the other road users. Many drivers admit after the accident that they were insufficient sleep for a day before the drive, worked overnight, and were not in good condition of health before the drive. Based on the report by World Health Organization (WHO), it was indicated that approximately 1 to 1.24 million people have died. Also, 20 to 50 million people were injured caused by accidents on the road across the world. Most traffic accidents globally were caused by drowsy driving, which is around 20% of traffic accidents across the world. So, developing a microsleep detection device is important to decrease the fatalities in an accident caused by drowsy driving. In this research, the development of microsleep detection device will be more focused on getting the data more precise and accurate. In addition, an effective methods to alert driver with a drowsy condition will be involved too. Okay, this is my literature review. Driver's sleepiness can be assessed using computerized, non-intrusive behavioral technique that track their out of ordinary action in the driver-based method. This technology employs computer vision via OpenCV, which employs a camera to detect a region of interest (ROI), which is the face, to detect change in facial features. If any of these signs of exhaustion are detected, If any of these signs of exhaustion are detected, an alarm will sound to alert the drivers. Percentage of eye closure per clause, for example, is a measure of eyelid closure of a defined period in which eyelid drops. Rather than blinking is used to show that a driver is tired when their eyes are closed at least 80% of the size. This method, however, is only effective if the driver's eyes are not protected, such as if he or she is not wearing glass. Furthermore, if it ignores the possibility that someone who is severely sleep deprived may doze off with their eyes wide open. Eye blinking can also indicate drowsiness. According to the result of the experiments, the previous system detect eye blink pattern with a 94% accuracy rate and 1% false position rate in JZQ eye blink database. Aside from that, drowsy people blink slower than awake people. For vehicle-based measurement, a few parameters are continuously analyzed, such as lane departures, steering wheel angles, and accelerator pedal pressure. If the parameter value surpass the set threshold, the driver is probably asleep. The ability to maintain lane position, how the accelerator pedal move, and how hard the brake are applied are all potential signs of driver awareness. These parameters are frequently extracted in a virtual environment using sensors connected to the various elements of the car, such as the accelerator pedal and the steering wheel. For instance, steering wheel movement, SWM use a steering angle sensor to identify driver drowsiness. Less steering wheel correction were made by fatigued drivers compared to those who weren't. The system has several limitations since it relies too heavily on the geometric characteristics of the road and on particular environmental circumstances. The analysis of driving behavior, MICROSLEEP, utilizing biological signals including EEG, ECG, EOG, and surface electromyogram and galvanic skin response (GSR) has been subject of various studies and research. The electroencephalogram (EEG) is most frequently used to assess sleepiness. Increased sleepiness is correlated with a decrease in frequency. It can be intrusive and even uncomfortable for the driver to have recording device linked to their body because EEG data is obtained using electrode put on the driver's head, which is a huge disadvantage. Sweat on the body of the driver may result in an inaccurate reading of traffic signal. Okay, this is my problem statement. Driving a vehicle with fatigue condition was the major cause of the unlucky accident that happened on the road. Some research state the different behavior of the driver while driving can be detected while in drowsiness. However, in other cases, the behavior of the driver are just a random habit of them while driving. The effectiveness of warning system at the previous microsleep detection device was low and did not alert the driver real time. Moreover, late detection of drowsiness can be affected by the accident and the result can be fatal. Apart from that, the method that has been used to collect the data such as electroencephalography (EOG) has some distraction to the driver because they need to wear a device that disturbs the concentration of the driver for the long term. So as the response to the issue state the objective of this research. Okay, this is the objective of the project. First is to develop a system that can detect drowsiness and prevent microsleep using three methods, which is eye aspect ratio (EAR), yawn aspect ratio (YAR), and percentage eye closure per clause. While to examine so this is my objective, to develop a system that can detect drowsiness and prevent microsleep using three methods, which is eye aspect ratio (EAR), yawn aspect ratio (YAR), and percentage eye closure per clause, while to examine drowsiness level. Second is to increase the effectiveness of the warning and detection system to alert the driver they are in drowsy condition, to identify the drivers of drowsiness using Karolinska sleepiness scale. So this is my scope and limitation of the project. This research will aim to develop a microsleep detection device by using three methods, which are EAR, YAR, and per clause. As for coding to be applied in this research to collect the data that required, some software will be involved, which is OpenCV, Unity 3D, and Python. The function of this software is to enable the features to detect the facial and locate the mouth and eyes. Two devices will be used to complete this development, which is a laptop and a USB camera. Due to a safety measure, this experiment just used simulation. Moreover, a modified Karolinska sleepiness scale (KSS) could be used to survey the behavior of the driver while driving. The long-hour driving factor is used to see the drowsy condition of the driver, and this experiment is participated by clean drug and or alcohol volunteers with a 2-year valid license and experience driving on the highway for a long time. The limitation of this research is the collected data just based on a computerized simulation that is inside the laboratory. In addition, just a few participants might join because the duration of driving with simulation is too long. Lastly is the environment in the 3D simulator is not in real driving. Okay, this is my methodology. Firstly is microsleep detector device (MDD) development. The primary function of MDD is to deliver an alert if a certain value in a respondent EAR, YAR, or per clause exceed a threshold. The operation of the device is shown in the graphic below, which include initialization, image capturing, and the gathering of AR, YR, and per clause data, the production of the warning system, and driver notification. The Viola-Jones face detector theory is used to locate face in each frame of the video to process the video image that was occurred by the camera. The system will find the representation of the eye and mouth after identifying a frame that contains a face. Then using the equation on the proposal project. Okay. Second is software and libraries. First is Python version 3.6, 3.8. Python has many applications including software development, task automation, and data analysis on large database. It can solve a wide range of problems and is simple to comprehend and understand. OpenCV, the experiment source code will take from OpenCV, which offer a wide range of real-time video processing tools. The system finds each frame face picture using the Viola-Jones object detector after the video frames are record, and each face image is then turned into grayscale image. Unity 3D. Since simulated environment have higher subjective tightness, creating a simulator that closely resembles real driving is essential. Okay, this is Unity 3D. Since simulated environment have higher subjective tightness, creating a simulator that closely resembles real driving is essential for experiments validity. Due to their adaptability and utility, simulations have also been frequently utilized to train personnel and even soldiers. For .NET and the C# programming language, Unity 3D is real-time 3D development platform that can be used to make 2D and 3D applications, including games and simulation. The third one is proposed participants. Around 10 students of UiTM Shah Alam will be participants to drive the simulator. Most of the students at this university already have a valid driving license with 2 years of experience driving on the highway. Okay, this is expected result. First one is vehicle-based measurement, EAR, YAR, and per class. Measurement of these three methods will be collected repeatedly during the driving session. For driving, the alarm would be active after the data was met the condition of drowsy of the EAR, YAR, and per class because most drivers have their duration of time before they feel sleepy. Second is Karolinska Sleepiness Scale. It is crucial to connect the data to KSS based on the behavior of the drivers as observed during the experiment. KSS is highly correlated with EEG characteristics, making it valid to be used to scale sleepy driving behavior. KSS therefore must be applied to characterize the change in the driver's mental state. Third one is evaluated and compare data on the graph by using categories of gender and confidence. The data of the experiments will be collected based on categories of gender with a graph to generate the result, and discussion influenced by gender. The survey before and after the experiment will be given to the participants to determine their confidence level in driving and be compared with their drowsy levels while driving. That's all for me. Thank you.